So the next thing we will need to know is if we are going to be able to handle polynomials, I suppose we should go through some operations. And one thing that we definitely have to be able to do is to add or subtract polynomials. So we're going to add or subtract polynomials. And the way we do that is that we combine like terms. So we add or subtract like terms. So we combine like terms by addition and subtraction. Recall that like terms are terms that contain exactly the same variable or variables raised to exactly the same powers. So we do that, of course, add or subtract like terms by adding or subtracting the coefficients of those like terms. Cram in my coefficients right there. There it is. Okay. So what does that mean? Well, let's take a look at this first one right here. We've got 5x squared minus x plus 6 added to negative 2x squared plus 3x minus 11. I always add in a few extra steps when I start illustrating this. And the very first thing we would do is drop these parentheses when and where possible. So we're going to drop our parentheses, get 5x squared minus x plus 6. We could just drop the parentheses there because we assume there's a positive in front of that, plus negative 2x squared plus 3x minus 11. Now the next step is optional, but it will help you to visualize this. And I can, by my commutative property of addition, change the positions of like terms so that they're next to each other. So 5x squared is an x squared term, and the only other x squared is minus 2x squared. The negative, the subtraction sign, comes along for the ride, by the way, with the 2. So be very careful with that. We have minus x, and of course we have plus 3x as an x term here. And of course we have that positive 6, and we have minus 11 from our constant terms at the end. Now we can combine these by combining the like terms. And I will point out, if you have 5x squared and you take away 2x squared, you will be left with 3x squared. If I have negative 1x and I add a 3x, I'm going to get plus 2x. And of course, if I have 6 and I take away 11, I'm going to get negative 5. So this would be my resulting expression from this addition. All right, not bad. Let's try it again. This time, let's work with this one. And the difference here is that we have a subtraction going on. So we want to get rid of parentheses first, but we have to be very careful that if there's a negative in front of that, we want to distribute the negative to all of the terms inside of the parentheses. Right? A negative in front of a parentheses means to distribute the negative. Distribute the negative. All right, so in this case, what's going to happen when we write it? Well, you should get 4a squared minus 7a. We're going to be subtracting negative 6a squared, so that becomes plus 6a squared. Subtracting positive 5a, so that becomes minus 5a. We're going to be subtracting negative 7, so that means plus 7. So now we can go through and, just like we did before, carry out our addition. We're just going to combine our like terms of 4a squared and our 6a squared. We're going to take our negative 7a and subtract 5a from it. And then we're going to add 7 at the end. So if we combine our like terms, we should get 10 times a squared, 4 plus 6 is 10, minus 12a, because negative 7 minus 5 is negative 12, plus 7. There is no other constant term. So this is our simplified expression. Sometimes you will see this even put into a weird looking format, but it pretty much means the same thing. Here's an example of that. This is from business. Sometimes we will get something called revenue and price, and we're looking for a total of price minus revenue. So we might think, well, let's say we've got a revenue equation of r of x equals 3x squared minus 4x plus 7, and a profit, it should be profit, pardon me, not price, profit function of x squared minus 2x plus 7. How do we find t of x, which is p of x minus r of x? Well, all the p and the r do is stand in for our polynomials. So what we're really saying right here is that our polynomial t of x is formed by subtracting everything in p of x, and in this case that's x squared minus 2x plus 7, and we take away r of x, which is 3x squared minus 4x plus 7. So this is just like every other addition subtraction problem we've done. We're just going to drop our parentheses. In the first case, we could just drop it by taking x squared minus 2x plus 7, and then distributing the negative to each term inside the parentheses. Be very careful to make sure that you do that. The negative times 3x squared is minus 3x squared. We would be subtracting negative 4x squared, so that's going to be the same 4x. So we're going to just add 4x here now. We're going to take the negative of positive 7, so that's minus 7. So when we add these together, what happens? X squared take away 3x squared gives us negative 2x squared. It's okay to end up with a negative number as a coefficient. We don't mind as long as it's a real number. We add negative 2x to positive 4x, and we get plus 2x. And if we add positive 7 and negative 7, we get 0. So our function t of x is now negative 2x squared plus 2x, and that would be our answer. Good luck with your assignments. I'll see you again in class.